1, 2. Okay, where's my... Looks like that's working. Why we no get sound here? What's the problem? Oh, that's the problem. One, two, three. Where's my... Why can't that be up there? Okay, let's check if that's in balance now. Check if that's in balance now. Close enough. Okay, I think we're ready to get properly started here. Okay, I don't want this one. Let's try doing fundamentals. Okay, this is still trying to load. Wait, why don't I have... Let's try doing fundamentals. What's up with the webcam? It's not plugged in. Why is it not? Is this the right thing? Yeah, that's plugged in. Where's the... That seems to be working. Okay, I'm gonna have to drop the stream. Okay, let's common denominators. You will have let's train. What's up with the low quality there? Auto. Oh, it's just automatically giving me low quality playback. Okay, fair enough. Instructions. You will have a list of rationals in the form number 1, denominator 1, number n, denominator n, or variations on that, where all numbers are positive ints. You will have to produce a result in this form. n1, comma d depending on the language, see example tests. I don't get it. Let's see what the output is supposed to be for this. Oops. I'm gonna have to pass. Oh, B is what the output should be. Okay, that makes sense. In which D is as small as possible and n1 over d equal number 1 over denom 1 times the number n over denom n. The contour of x 1, 2. Oh, I get it. What level is this? Oh gosh, okay. So, there's two parts to this problem. I have to find the least common denominator of each of the second numbers in that list. And then once I determine that number, I have to scale Gosh, that's tricky. Well, let's assume that I know that the... Let's see. Least common denominator equal 12. I know that's the case in this sample test. So let's put together... Let's put this together. What am I trying to say? Oh, let's assume that we've solved that part of it and implement the second part of it. Okay. 3.4, I'd rather have 3. I guess 3.6 is what's going to be. Okay. So 1 and 2 has to become 6 over 12. So we multiplied it by 6, which is 12 divided by 2. So for, let's call it for fraction in list. Why does it not? Maybe it doesn't automatically. So for each one of these, factor equals fraction, no, equals least common denominator, divide by the second thing in fraction, so fraction index 1. And then fraction at position 0 and fraction at position 1 equal, you know, I'm going to do these on separate lines. I'm better at thinking that way. Actually, I can just multiply by the factor. Times equal factor, not faction. Fraction 1 times equal factor. And I think that's gonna modify the list in place. So let's see if I'm gonna get this right in the first sample case. I should return something probably. Try that. That's funny, the empty case worked too. I know if I try more cases it's gonna fail. So I'm sure I could look up an algorithm for least common denominator, but I feel like there's a better way. I mean, I'd like to at least try to do that myself. In this case, the product of 2, 3, and 4 gives us, does it? 296, no, 24, it doesn't do that. Yeah, I'm probably gonna have to look this up. Oh, hey, kitty. Alright. Why is this not working? Algorithm least common. Wait, least common. Oh, that should be least common multiple, shouldn't it? Yeah. Easiest way to get the least common multiple numbers is to express them as a product of prime numbers, factorize them. Okay, fair enough. If we multiply together all prime numbers used in these products in their highest power, we will get the least common multiple. Find the least common multiple of 6, 8, and 15. 2 to 1, 2 to the 1, 2 to the 3, 5 to the 1, 3 to the 1. Okay, it's 120. I get that, but how do I don't care about the much more effective way to get the least common multiple of two numbers is to multiply them and divide by their greatest common divisor. The greatest common divisor may be computed by the Euclidean algorithm, which is fast because it does not require factorization of the given number. Greatest common number of 140, 72 equals 4. I guess I need another algorithm for greatest common divisor. Okay, here we go. Integer factorization is computationally a very expensive algorithm. Hence we use the Euclidean algorithm to calculate the greatest common divisor of two natural numbers. The Euclidean algorithm does not require any factorization at all. It would be interesting to implement the factorization case, but I'm going to go for the efficient one for now. The Euclidean algorithm takes as input two positive a and b and assumes the greatest common denominator of a comma b equals greatest common divisor. Greatest common divisor of b comma greatest common divisor of a comma b equals greatest common divisor of b comma a mod b. This theorem can easily be proven. In each step the algorithm divides a by b. If the remainder is not equal to 0, then the producer sets a value of b into the variable a and the remainder into the variable b and repeats the step division. If the remainder is equal to 0, then the algorithm returns the value stored in b. It is the greatest common divisor of original numbers a and b. So we'll find the greatest. Okay, I'm gonna have to look through this example to figure this out for sure. Find the greatest common divisor of whatever, of numbers 133 and 15. 133, huh? A equals x times b plus remainder. 33 equal. Where did that 8 come from? What? Might be time for an easier one. Is that the 133? Greatest common denominator of b and a modulo b. So if we take 133 and divide it by 15, I'm assuming we get 8. I'll check that. Can you make an Octave band's audio visualizer on JavaScript using Web Audio API? I could. I don't think I know how to do that. Okay, Octave band's audio visualizer on JavaScript using Web Audio API. I don't know. I'm not exactly making progress on this problem, so why don't we play around with that. And hi, Andrew. The coding train. Is there a training somewhere that you're talking about? If so, drop that in the link, and I'll see if I can help you figure this out. But let's see. Web Audio API. Let's see what this is. Audio nodes, audio routing graph, several sources. Here we go. Basic concepts behind this is inputs, effects, destination. I guess I could HTML5 audio visualizer. Let me check out an example of. Gonna check out this example. Built with HTML5 audio API. So what I think I'm gonna do is, rather than try to build them from scratch, because I haven't done something like this before, I have my camera's up here. I am going to, it's weird because it looks like the chat is over there, but the camera is over here. Anyway, I'm going to dig into this and see if I can figure out what's going on. That's a bit intimidating. And by the way, does this have a logarithmic frequency scale? I'm not I'm not sure if I can tell just by looking at it. A lot of what's in that code could be just the you know, the file input stuff. Is audiomotion.js better than HTML5 audio visual by Wayu? I have no idea. Not even the foggiest. What is audiomotion.js? I'm not seeing an obvious... Oh, well, maybe this is it right here. High resolution real-time spectrum analysis. Well, this one looks fancier than the last thing I was looking at. So this is something that's already been put together and looks pretty impressive. I'd love to... I'd love to dig into this. I think it would take a kind of a lot for me to figure it out, but this looks really like it'd be some interesting code. Discrete frequencies mode looks more like Ableton's Spectrum device. I don't know. What I'm going to do is take a screen cap of what you've asked, and I can look into this later and maybe publish a video on it if I figure something out. Because why is this not working? Try again. Okay, whatever. Do this another way. Discrete frequencies mode on audiomotion.js looks like Ableton Live's Spectrum. I haven't used Ableton Live. I've used Logic, the Apple Music app. I'm sorry, I don't really know anything about this. I'm going to go back to the CodeWars algorithms. So if you're interested in that, hang around. And if not, that's cool too. I'm going to look for another greatest common divisor algorithm. This might be easier to figure out. Coding a logarithmic frequency scale analyzer, please. I got nothing. I really cannot do that. Not today, anyway. You know, maybe I can brute force this. Except I don't even know how to do a brute force implementation to find a least common multiple. Just for fun, I'm going to attempt it and watch it tell me that things are wrong. Wait, there's an error? What? Did I change anything? Unexpected indent. Oh, wait, what's going on here? That looks better. Wait, there's non-integer numbers here? That's weird. Oh, but the... You know what? I'm gonna try something significantly easier than this. Let's see. I'm gonna look for 6Q. That's easier than 5. What's in a name? Try this one. Or rather, what's a name in? For us, a particular string is where we're looking for a name. Task. Test whether or not the string contains all the letters which spell a given name in order. The format. A function passing two strings, searching for one, the name, within the other. Function, name, and string. String name, return true. Wait, what? Examples. Name and string. Across the river, Chris. C-H-R-I-S. True. Contains all the letters of Chris in order. Contains none of the letters of Chris. Contains only some of the letters of Chris. Contains all of the letters in Chris, but not in order. Contains all of the correct letters of Allison in order, but not enough of all of them, missing an L. I think that just means you need to go letter by letter. Andre says, making audio spectrum analyzer using dsp.js library and analyzing node.get float. I don't know how to do that. I'm sorry. I really have no idea how to do that, and I don't fancy trying to figure it out on stream. Okay. Test whether or not the strings contains all the letters which spell a given name in order. Let's start coding. I think I got some ideas here. Also, we can go full screen with this. If it'll load. My thought is to do a for loop through name, and then for each letter in name, look for... I'm gonna have to... Right, for... I'll use, say, letter in name. Alright, gonna need to look up some documentation. I'm searching for... Python loci character and string. And actually, I'll bring that over onto the screen so you can... Find method returns the lowest index of the substring if it is found in the string. If it is not found, then it returns -1. Okay, good. Sub, start, and end. So... we're over here. I can do string dot is str a keyword? I'm not sure if it is. String dot find of letter, but now we need to think about the start and end. End is at the end, so I don't need to specify that. I'll use an I here. Let's try to find letter I. I guess if string define if it's in there, that's good. We'd say I. Where's tab? We increment I plus equal 1, so we step up to look in the no. What does it return? Returns the lowest index of the substring if it is found. Okay, that's okay. We can work with this. If it's not found, so if it's this is if string dot find that not equal to 0, then I equals. I guess I'm gonna need found index equal string index string dot find of letter comma I if found in index. I could do greater than 0, but I'm just going to say not equal. I think that's probably more efficient to check not equal -1 rather than trying to check a greater than or less than situation. So then I equal found index, and I think that's going to have to be that +1, because we want to start looking at the next thing. Okay, what do we have now? Okay, what else? I have to return false here, because if it didn't find it in there, then it's not in there. And once that's done, if it makes it through all the way through that loop, then we return true. Let's try some sample tests. Huh. One, two, three, four. 1, 2, 3, 4. So why did I get... Oh, I just need to deal with capitalizations. String equal string str dot lower. That should fix it. Wait, still no? Why didn't that make a difference? And why did that return false? Just out of curiosity, what if I take away that +1? Does that fix it? I'm surprised that doesn't even make a difference. Can I break it by saying like +7? Is that even gonna make a difference? Okay, I'm getting a lot of these right just because it's finding false, which is fine. But the true ones are failing now. I'm going to go back to +1 because I think that's the correct way. So I've gotten the true that I should have gotten there. False, 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 false. True, true. I'm not getting true here. Why not? Python string lowercase. That's what I thought. Lower. String.lower converts the string given into lowercase and returns the string. So str equals str.lower. Alright, let's see what happens if we print str. Run sample tests. Okay, that works. Oh. I have to do the same thing with name. Okay. There we go. Boom. Got it. I'm not going to bother with refactoring right now. Oops. Wait, what? I just solved it, right? What gives? Let's try this again. Good thing I had copied it down, because I might have had to submit final. There we go. Oh my, there's a much shorter way to do this. IT equals iter. IT equal iter of string.lower. So I don't know what iter does in Python. The iter object creates an object which can be iterated on one element at a time. Why is that important? Doesn't Python just like make that work automatically? Return all C in it iterable for C in name.lower. Why does that work? Return. Alright. That's true. Returns true when all elements in a given iterable are true. If not, it returns false. C in iterable. If C is an iterable for C in name.lower, this, I don't see how this covers the ordering problem. I don't see it. This one looks like it's pretty much the same idea of... Looks like the same idea as mine. Let's compare with my solution. I think it's basically the same thing. For C in text.lower... Oh yeah, that's clever. Saved a line there. If C equal name 0.lower... Oh, okay. Name equal name 1 to the rest. If not, return... If not name... Return true. Return false. For C, if C meets the condition, do all of that. If C does not meet the condition, then return false. The condition is C in text dot so they're putting their first for loop through text. Oh, that might... this... Okay, they're coming at the problem from the opposite direction than I did. Okay, that's enough of that. Next one. For Q? I don't think so. That's way too hard for me. I'm gonna stick with 6. Okay, that one's done. 1207 kata found. That's awesome. Okay, banker's plan. On second thought, maybe I'm gonna call it a night. Yeah, I was aiming to be done working on coding around this time tonight anyways, so I'm going to cut off the stream. Sorry, Andre, I gotta go. Thanks for stopping by.